In the previous chapter, what we talked about was how the heat was transferred from one object to the other. Things that you need to remember from the previous chapter are things like the heat is moving from a hot object to a colder object. So when we have an object that is object, let's suppose that this is object A and this is object B, and imagine that object A is with a temperature higher than object B, which in other way, how do we say it, is that the object A has more heat than object B. Then the heat is transferred from object A to object B until that is known as the thermal equilibrium is reached, meaning that the two objects together will have pretty much the same temperature. The way that heat is transferred from object A to object B is in three. So the first one is conducting. When the two objects are in contact with each other, The second way that the heat is transferred is convection, in which the two objects are not in contact with each other. So this can happen when the air flows not in contact with each other. And the third way that we will study on this class, that the heat is transferred from one object to the other, is the radiation, which is happening as a result of the electromagnetic waves, which carries energy, and they are moving from one object to the other. So I will say here electromagnetic waves. Now, on the other chapter, on chapter 5, the other thing that we discussed is the difference between the heat and the temperature. So heat is the amount of thermal energy that the object has, meaning that if you have more particles of the object have. So if you have more particles in an object, then the heat that this object has is higher than the other object, which may have the same temperature, but it has a smaller amount. So the heat is the total amount of energy, amount of thermal energy that particles of matter have, versus what temperature is the average of kinetic energy that particles have. And since it is the average, it depends on how many particles are on it. Average of kinetic energy. Now, and beside this, what is the difference in terms of heat and temperature? Is that heat is energy and is measured in joules, while temperature is a scalar, and it is measured in degrees Celsius or Fahrenheit or Kelvin. degree Kelvin. What we will see in this unit is mostly the degrees Celsius. The other thing that we saw on chapter 5 is the fact that this kind of motion of the particles of the air is creating that is known as the sea breeze and land breeze. So sea breeze, you can refer for more into the previous videos, and land breeze, where you feel the cold that is coming from the sea during the day, and the heat that is coming into the land during the night from the water. So this is pretty much the summary of chapter 5, and now we will move on chapter 6. And the very first thing that we will see on this chapter is how the heat is absorbed and lost into from one material to the other. What is that characteristics? What is that thing, that physical quantity that makes some objects to absorb more heat than the others? So you probably have noticed that if you are, I don't know, seated in a sand during a sunny day, you will notice that the sand is hotter than sitting in a piece of metal. So different materials absorb heat at a different rate. The way that we represent that rate of absorption of different materials is through that is known as the specific heat capacity of the material. Specific heat capacity. It is the specific heat capacity is unique for each object. So each material will have a unique value, and that value is telling us how much heat it needs to absorb, how much energy it needs to absorb or release, so that the 1 gram material, it is increased or decreased by 1 degree. Okay, there are a lot of words here, but I will try to explain it in simple one. So if you have 1 gram of material, and then you are either increasing or decreasing, doesn't really matter. This material, those particles, by 1 degree Celsius, then the heat that is absorbing is measured in joules, as we said prior here. The heat that is absorbing is that number. So when we have, let's suppose, 0.99 joules per grams degree Celsius, those are the units of the specific heat capacity. What it means is that if we have 1 gram of material, or particles of this matter, and we are increasing or decreasing the temperature by 1 degree, then the heat that is absorbing on the case of increasing or is releasing on the case of decreasing the temperature by 1 degree is 0.99 cents. So when we have this number indicates how much joules, how much heat is needed to increase or decrease the temperature by 1 degree of 1 gram matter. So when we compare those numbers, so if we have, let's say, the specific heat capacity of water is 4.19 joules per gram degree Celsius, meaning that it needs 4.19 joules of heat to increase the temperature of water by 1 degree, and the amount is only 1 gram. And if we compare those two numbers, then we can say that this material here that has a higher value for the specific heat capacity is absorbing more heat than this material here that has a value of 0.99. And this is the meaning of specific heat capacity. In your textbook on table 6.1, you have the value for some of the common matters that you will see in the value of their specific heat capacity. So you will see values like water is 4.19, as we mentioned here, or motor oil is 2, and vegetable oil is 1.19, and so on. So if you see those numbers, then you can draw the conclusion that the material that absorbs the least amount of energy in this list that we have here, the least amount of energy to increase the temperature by 1 degree or decrease the temperature by 1 degree to release, in that case, the heat, of 1 gram material is copper, because the amount of the energy is 0.38, and then it goes up. Iron has a higher specific heat capacity, meaning that it requires more heat per 1 gram of iron to increase the temperature of 1 degree. And then sand is 0.66, glass is 0.84, air is almost 1, and so on, and water is the highest one. And this is why we even feel the sea breeze and the land breeze, because it is slowly absorbing it, and it is absorbing a lot, and then it is releasing it at night to bring the land breeze into land, or hot air into land. This is for 6.1. Now you can go to page 110 on your textbook and complete the questions on check and reflect. Check your understanding.